So this is electrolysis, extra electrolysis for the triple scientist. So the first one, nice easy question, kind of relates back to the prac from last year. Looking at 100, calculate the mean of the results that are reliable. So obviously 0.2 is too far out, it's not repeatable. So you just do them two, divide by 2 because you're only using 2, and calculate the mean. Describe the relationship between the current and the mean volume of hydrogen. Again, not really any science related from here, it's just using what you can see. So as the current increases, so does the mean volume of hydrogen produced. Using the results for the current 300 MA and the following equation, calculate the percentage error. They will give you this equation if they want you to calculate percentage error. Furthest volume from mean volume, you could have gone either way, either 1.2 or 1.4. Take away the mean volume, divide by the mean volume, percentage error. If you'd have done 1.2, you would just got minus, so there's no issue with that. Then goes on to ask you to balance the following electrical equation, showing the electrolysis of water. So you're making 2 hydrogens, so you're going to need 2 positive ions, that means 2 electrons. Remember, oxygen's a little bit weird because it's -2, so technically for 1 oxygen you'd need 2 electrons, but you're making 2 oxygens, so you need 4 electrons. In your opinion, does the advantages of hydrogen fuel outweigh the disadvantages? This is a question that the whole year group could be asked. Hydrogen is a very explosive fuel, which is hard to store. However, it releases no CO2 when burnt, so has no effect on global warming. So, question number 2, the electrolysis of copper sulfate solution was carried out using the apparatus below. The apparatus all look the same with the same electrical current and a positive and a negative. Identify the electrolyte. Okay, remember that's the solution that you're quite trying to break up. So this would be copper sulfate. Give the name given to the positive electrode. Okay, positive anode, negative is cathode. Again, calculate what's it say here? The following results were obtained during the electrolysis of copper sulfate solution. The mass of the negative electrode was measured at intervals. The initial mass of the negative electrode was 20.2. So then it asks you to plot a graph and complete the table to calculate the mass of copper disposal after 40 minutes. So taking it away from each other, because you know the initial mass is 20.2, so just taking it away, then plotting on a graph. It is a curve, could have kind of tailed off a bit better by there. And then it says use a graph to find the copper deposit after 30 minutes, so up and across. Actually, quite a nice question for 7 marks, that. So again, showing you the apparatus. Okay, remember the apparatus for the electrolysis of water is a little. So name this process electrolysis. The table below shows the volume of hydrogen formed over 10 minutes. Plot the results from the table on the grid opposite and draw a suitable line. Label this line hydrogen. Okay, so nice and easy. Just plotting results they give you in the axes. Draw a second line on the grid to show the volume of oxygen that would be collected in the same time. Label this line oxygen. What I did then, because that ended at 20, so I wanted to end at 10 because there'll be twice as less, that's all the proper English is it, so there'll be less because you make 2 hydrogens for every 1 oxygen, looking at water there, so you have half a line. Hydrogen burns in air, forming water. The reaction is represented by the following simple equation. Use the key to below, so this is nice, this is space filler diagrams from last year. Okay, remember the lone element always goes in the middle, just using what you've got to make 2 waters. So, explain why copper ions move towards the cathode. Copper has a positive charge. It is attracted to the negative cathode. Remember the panic anagram, negative is cathode, where it will gain electrons. Balance the following electrode equation to show how copper forms the cathode. So it's 2 plus, so plus 2 electrons. Using only reliable results, calculate the mean of the copper deposited at the 0.5. So it's only them 2 because 0.9 is too far out. Mean mass of copper deposited is 0.2. Calculate the percentage error of the unreliable result at 5 volts, okay? So difference between the result and the mean, so it's like the furthest one away, divided by the mean result. So percentage error, if you included that, would be 45%. Use the results to predict the mass of copper deposited after 1 minute when a voltage of 8 volts is applied. Okay, so I used the 4 volts one, you could have used the 2 volts one, could have used any of them, and I just times it by 2, imagining that it was going to carry on going up the same amount every time. So twice as much as when 4 volts is used.